Hello, Algebra 1 students, and welcome back to your Semester 2 final review. We're on to problem 24, which comes from lesson 8.10, 8.10. They are asking which of the following is a factor, right? Factoring, big theme, of 3x squared minus 12. So I will, as always, give you two ways to do this problem, and it is pretty tricky here. The first way, the way that they want you to do this, is they want you to say, well, every time you factor, before you actually use the box, you should see what the terms have in common, especially if there's only two terms. So looking at these two terms, we think, do 3x squared and negative 12 have anything in common? Yeah, I think they each have a 3 in common. So I'm going to divide out the 3 here. That'll leave me with 1x squared minus 4, right, if we divide each of those by 3. And then they want you to recognize this pattern, something squared minus 4, which I might remind you is a perfect square. That means that we can actually skip right to our factored form because this is going to be a difference of squares. To get to our factored form, I know to make x squared, it's got to be x and x. It's like the square root of x squared. And to get to our other answer, think the square root of 4, it's got to be 2 and 2. To make the negative 4, though, 1 has to be negative, 1 has to be positive. And so this is our fully factored form of 3x squared minus 12. They ask which of these is a factor. Well, there are three factors, 3, x minus 2, and x plus 2. I think the only one that appears up here is x minus 2. Now, to quickly prove to yourself why this is a factor, look what happens if I do x minus 2 and x plus 2. We get x squared. We switch colors. We'll get x squared, positive 2x, negative 2x, that's key, and negative 4. When you multiply two binomials, one positive, one negative, this is called conjugate pairs. These two in the middle will always cancel out and leave you with the x squared minus 4. Now you might be thinking, well, what if I didn't remember to do that? That's okay, you can still get the answer, and here's how. We could go through and we could say 3x squared and a minus 12. Now typically when we factor, we think ax squared plus bx plus c. And if there's no x in the middle, we can always add in a 0x. From here, you could certainly go through and try the box method. All right. Now, when you do this box method, there are going to be a couple different options here, and I'll try to show you both of them. Okay, 3x squared, negative 12. We have to split up 0x, which seems strange, but it is certainly doable. Right, adds to equal 0, multiplies to equal the diagonals, which is going to be negative 36x squared. Okay, if it's 0, then my two factors need to essentially be 0 apart. 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Which of those are 0 apart? Well, 6 and 6. 6x, 6x. In order to multiply to make a negative, one of them has to be negative, and 6 minus 6 is 0. So 6x and negative 6x. Now this is the part where you might get a slightly different answer than I, and that's okay. I'll show you both, but both of them will ultimately work out. Because if you look at the 3x squared and the negative 6x, they certainly both have an x in common, but they both also have a 3. And this is where this box method kind of breaks down, because you might notice over here that these two both have an x in common and they both have a 3. But that would be a mistake, because 3 times 3 is not 3. This one has to be just a 1. Now depending on how you do this, you might have given this one a 3 and this one the 1, and that's okay. It doesn't matter which one, but one of them has to have a 3, one has to have a 1. So again, I'll show you both ways, but if you did it this way, 3x times negative 2 will get you negative 6. X times 6 will get you 6x. And so this would give me 3x with a positive 6 and x minus 2. Now this is not in fully factored form, because if you look, there is a 3 in common here. So I can divide the 3 out, and that would give me x plus 2 and x minus 2, which is exactly what we got before. All right, the other option, as I mentioned, is you could have swapped the 3 over here, and that'll change our numbers. Negative 6, positive 2. So positive 2 and 3x minus 6. Same idea though, right? We have a positive 2. You need to factor out the 3, and this would become an x minus 2. So it just switches the order, but you can still see that one of these factors is present up above. So hopefully this was a nice quick run through. Recognizing a common factor in a difference of squares is the fastest way to do it, but if you don't, the box method still works. Just don't forget to take out any common factors that occur at the end.